This is a quick review of rational and irrational numbers. How can we classify numbers? Well, a number can either be rational or irrational. A rational number is a number that can be written as a fraction, for example, a over b. Within rational numbers, they could then be integers, which would be whole numbers. And then also, we sometimes call whole numbers natural numbers. So anything that can be written as a fraction would be considered rational. To write any rational number as a decimal, we can divide the numerator by the denominator. If we divide and end up with a remainder of 0, that's called a terminating decimal. If we divide and end up with a digit or group of digits that repeats infinitely, then it is a repeating decimal. So a terminating decimal would be something like 0.5. A repeating decimal would be 0.3 repeating, or 0.67 with a 7 repeating. So repeating would have a bar over it. Both of these examples would be rational because they can be written as a fraction. 0.5 is a half, 0.3 repeating is 1/3. Writing a terminating decimal as a fraction. Here's an example. 0.4, it stops, so it's a terminating decimal. When we read this, we could say 0.4, or we could say 4/10, because the 4 is in the tenths position. Going over to part B, this is negative 1.905. So this is the tenths, the hundredths, and the thousandths place. So then we could rewrite the 905 as 905 over 1,000. So when it is terminating, we can always write that as a fraction. When it is repeating, there's a little more math to writing out that fraction. So let's take a look at an example. 0.48 repeating. Step 1 would be to write this as a fraction by first letting x equal 0.48 repeating. Then what we're going to do is, because there's 2 decimal places, which would mean there'd be 2 zeros to get that to come over on the one side, we would multiply by 100 because there are 2 repeating digits. So then we get this statement here. So here's where we're starting. 100 times x would give us 48.484848 repeating. Then what we're going to do to get rid of that x, we're going to subtract it. So an x, as we started at the beginning, was equal to the 0.48 repeating. So when we take that off, 100 minus 1 is 99. And then when we take the 0.48 off, we get that repeating decimal away. So then we're left with 48, and then 99x is equal to that. If we perform that operation to get x by itself, we get 48 over 99, and there is that repeating decimal we were trying to rewrite as a fraction. And that fraction does reduce, so that's what we're getting, 16 over 33. Let's try another one. Write the decimal as a fraction or mixed number. 0.207 repeating. First, we're going to let x equal that repeating decimal, and then we're going to need to figure out what number to multiply by. So I see the repeating pattern happening 3 decimal places. So that means we're going to multiply by 1,000. So we have 1,000 times x. So to move that 3 positions, that takes 1,000x. Then we want to do the subtracting to get rid of the repeating decimal. So we're going to subtract exactly what we defined up here. So on the left side, I'm subtracting x. On the right side, I'm subtracting that repeating decimal. So when we perform that subtraction, 1,000 minus 1 gives me 999. And over here, repeating decimal gone gives me 207. So to solve for x, we would divide by 999. And on the calculator, we're getting the 207 repeating. And our goal is to write that as a fraction, so then I want to convert the 207 to 99 into its lowest term. So our answer would be the 23 over 111. So, if you have a repeating decimal, it can always be written as a fraction. So here are some examples. What I want to do is decide whether it's going to be rational or whether the example is irrational. So we're going to ignore these directions here. So rational means it can be written as a fraction, irrational means it can't. So 8 can be 8 over 1. Negative 7 can put it over 1. 0.25 is a terminating decimal, so that is rational. And some of us might know that one as 1/4. 7/9 is already a fraction. Here is a repeating decimal. As we learned today, a repeating decimal can always be written as a fraction. And this one is 2/3. This is a terminating decimal. That means that it has an end that can also be written as a fraction. Going down to the bottom, it looks like all of these can be written as fractions. The ones that cause us problems would be pi, the square root of 3, the square root of 5, and many others. So these would be 3 numbers that would be irrational. This concludes my video. Remember, a repeating decimal is a rational number, and a terminating decimal is also a rational number.